Hello, I'm Professor Rad, and today we're going to talk about subtraction when there are a lot of zeros involved, which doesn't sound like a problem, but it's going to be a problem. So we're going to use three different techniques to find this difference, so you can see which technique is going to work best for you in situations like this. So we're going to subtract 6 and 842 thousandths from 24. And the first method we're going to try is the left to right method. Now, subtraction phrasing can be a little bit tricky. Whenever you see this subtracting from, the from comes first. So both of those start with F. That's how I remember that. So from is first. So we're going to write the 24 first. Then we're going to subtract going from left to right. So the first digit on the number we're subtracting is the 6. So we're going to take 6 away. And we can count down for this one. So 24, 23, 22, 21, 20, 19, 18. So I end up with 18. Next, I'm going to have to subtract 8 tenths. So I'm going to put a tenths place here so that I can subtract 8 tenths. For this one, I'm going to draw 8 dots for me to count down. 1, 2, 3, 4, 5, 6, 7, 8. And remember, when you're subtracting using left to right, you can kind of ignore that decimal point, pretend it's not there. So I have 180, and I'm going to count down 8. So 180, 179, 178, 177, 176, 175, 74, 73, 72. So this will give me 172, making sure I put that decimal point in at the end. Okay, next we're going to subtract 4 hundredths. So notice the 4 is in the hundredths place. So when I write 4 hundredths, I have to make sure that that 4 is in the hundredths place. As before, in order to make sure things line up, I'm going to add a placeholder 0 there to help me subtract. Now I can think of this as 1720, or even just 20. That's how I'm going to think of this. So 20, and we're going to take 4 away. So 19, 18, 17, 16. And there's our 17. And then to finish, we had 2 thousandths. So again, there are 2 digits before that 2. So I'm going to have to put 2 zeros there to make sure the 2 is in the thousandths place. And now I have to add a placeholder 0 here. Okay, so let's subtract. I'm going to count down from 60. So 60, 59, 58. And everything else can just come down. So it looks like 24 minus 6 and 842 thousandths is going to give us 17 and 158 thousandths. So let's check to make sure we got this right. So I'm going to use the addition process to do my check here, and later we can check with like the traditional process to see if it's right. So I've got to add 17 and 158 thousandths to 6 and 842 thousandths. So I've got a 10 from 17, a 7 from 17, and a 6 from up here. I've got a 0.1 and a 0.8, a 0.05 and a 0.04, and a 0.008 and a 0.002. So I've got 10, 7 and 6 is 13. So that's going to split into another 10 and a 3. A tenth and an eighth is a ninth. A 5 hundredths and 4 hundredths is 9 hundredths. And 0.008 plus 0.002 is going to be 0.010, right? So 8 and 2 make 10. So this is the same as just 0.01, which this is going to make 0.10. I'm running out of paper here, which is the same as 0.1. So 9 plus 1 is 10, so that gives us 1.0, which is the same as 1. So that gives us a 4, and that's a 20. So 20 plus 4 gives us 24, which is what we subtracted from. So since we got what we subtracted from, that means that this answer is correct. Now let's do the subtraction problem using both the Singapore and the traditional method. So I've set up my Singapore method here. Oh my goodness, I apologize if you hear some construction or traffic outside. It gets a little bit noisy here. So when I write this, I want to make sure that I'm lining up my place values. So 24, there was no decimal point written, so the 4 is in the ones place. And for 6.842, the 6 is in the ones place. So I'm going to put some placeholder zeros here as well to make sure everything lines up. Now remember, with the Singapore method, you want to start from the right, move your way left, and the first place where the top digit is smaller than the bottom digit tells you where you're going to subtract. And we run into an issue right away here if I try to do 0 minus 2. So I want to subtract this 2, but this 2 is in the thousandths place. So I'm going to subtract 2 thousandths. Remember, on the bottom, this makes it easy. We're going to get 6.840. And on the top, I'm going to have to count down. So I could think of this as like 24,000, and I'm going to take 2 away from that. So 24,000, and then that would be 23,999, 23,998. And I can do a double check by counting up. 23,998 plus 2 would be 99, and then 24,000. Now it looks like we are good to go. 8 minus 0 is 8. 9, let's take 4 away, so that'll be 8765. 9 minus 8 is 1. And then to finish, I'm going to do 23 and take 6 away. So 23, and then let's do 1, 2, 3, 4, 5, 6. So 23, 22, 21, 20, 19, 18, 17. So we get 17 and 158 thousandths. Yay, and that matches what we got before. Sweet. All right, let's try this one more time using the traditional method. So for the traditional method, you want to make sure that you also line up your decimal places. So I put the 6 underneath the 4 because they were both in the ones place. And as we did with the Singapore method, I'm going to have to add zeros to make sure I have something in each column. Now, in this case, again, I can't do 0 minus 2. So this 0 runs to its neighbor, but its neighbor doesn't have anything to lend out. So it runs to its neighbor, but that neighbor doesn't have anything to lend out either. So it runs to its neighbor, and the 4 lends 1 out. So the 4 becomes a 3. That will let this 0 turn into a 10. So now it'll turn into a 9. So the next 0 could borrow a 10. So that turns into a 9, so the original 0 could turn into a 10. And now we can subtract. So 10 take away 2 is 8. 9 take away 4, 9, 8, 7, 6, 5. 9 remove 8 is 1. Bring down that decimal point. I can't do 3 take away 6, so I'm going to borrow again. The 2 turns into a 1, and the 3 into 13. So 1, 2, 3, 4, 5, 6. Let's count down 6 from 13. We have 12, 11, 10, 9, 8, 7. And then we bring down the 1. And good news for us, that matches what we got with the other techniques. So 17 and 158 thousandths. Looks like it'll check out. But I mentioned before we would use the traditional method of addition to check. So let's do that here. I've got my 17.158. And to check, I'm going to add 6.842. And when I add those, I should get 24.000. So 8 and 2 makes 10. So I write down the 0, carry the 1. 5 and 1 is 6, plus 4 is 10. Write down the 0, carry the 1. 8, 9, 10. Write down the 0, carry the 1. Bring my decimal point down. 1 and 7 makes 8. And 8 and 6, 8, 9, 10, 11, 12, 13, 14. Write down the 4, carry the 1. And 1 and 1 make 2. So we got 24 in the end, which matches what we had here. Okay, so hopefully seeing the subtraction with each of those 3 methods helped you get a sense for which techniques you might like the best. So I've got 3 problems here for you to try out. You could do a different method for each one, just to experiment with, or you could use your preferred method for each of these 3 and see if you get the correct answer. All right, in the next set of videos, we're going to move on from subtraction and we're going to look at some repeated addition. So instead of undoing addition, we're going to repeat addition, and that is what we're going to call multiplication. So I hope you found this video helpful, and I look forward to seeing you in the next one. Bye for now.